This video, along with my trip to Earth 2022, was made possible by whaleswares.com, your one-stop shop for all-inclusive 3D printed paint kits to printing on demand. Whatever it is you're looking for that relates to 3D printing, there's definitely something for everyone, so make sure you check them out. Links in the video description below. Hello everyone, we are here at the Do It 3D stand at Earth 2022, and right next to me here I have Ivan. I'm going to call you Ivan just so we don't confuse it. Ivan, tell us a bit about yourself.
Cool. So I'm an undergrad student at Imperial College London. I'm a design engineer student, and this past summer I've been working as an undergraduate researcher assistant with Freddie Hong.
So let's start off by explaining what's happening here. This is a Prusa MK3. It's not exactly stock. Mainly because it has two additional axes, and it runs on a Do It board.
Exactly.
Right.
Yeah.
So let's start off talking exactly what is happening here.
Yeah. So essentially, we've added two axes, two rotational axes that provide a tilt to the bed and a spin to the bed. You know, that we call this the U axis and we call this the V axis. And by adding these two axes of rotation, then you end up with 5 axes and allows you to create all of these complex geometries and shapes, and forget about supports as well.
So this runs on standard G code. Nothing special about the G code, correct?
Yeah. So Repra firmware on the Duet control, Duet 2, I think is the board. Yeah, and yeah, it's all standard. It's just two more axes of rotation. That's the whole point. Yeah.
So still riprap, running riprap. However, you did mention that it takes a special kind of process to actually make it do something. Let's call it something. Which is you need to use Rhino and Grasshopper, correct?
Exactly. Yeah. So in order to slice, because you cannot really call this slice anymore, we don't have layers per se. We have curved layers and stuff. So in order to do that, we've built a Grasshopper script. I have a huge Grasshopper definition, which inputs a substrate geometry and a path, and then it's able to calculate all the kinematics, all the maths is done on the Grasshopper script, and it outputs a G-code file, basically, yeah.
So for those who don't know, Rhino is like a CAD design.
Yeah, it's a surface modeling tool, which costs... That's the only part which is not open source of our project, is the fact that we have our slicing tools on Rhino, which requires a bit a license to use. But yeah, it's a surface modeling tool. And then Grasshopper is a plugin which built on Rhino, and it allows node-based CAD design, basically.
So, as you said, this is like, the project is open source. Yeah. Everything is open source except the software, of course, that you use to run the scripts. So people can actually try to attempt this themselves.
Exactly. So Freddie, as part of his PhD, he was just developing this to aid his research. At some point, he just made all open. So all out there, it's on that QR code. There's a link tree with a link to the GitHub repo where you can find the bill of materials and all the software tools. We've got some of the research papers as well, so make sure to check that out if you want to know more the nuances of the kinematics and the slicing. And we've got a YouTube channel as well, where we have more demos of the printer and an assembly guide, so if you want to build one.
So the pieces that are coming out of this thing are absolutely mind-blowing. I mean, it's pure art. How did you come about to, like, is this the introduction to your 3D printing life? Like, what are you doing at the moment with this machine? How did you come about to building this?
So, I mean, I started printing a few years ago with my Ender 3, planar stuff. Yeah, it was pretty chill. Then I went a bit into multi-material stuff with Race 3Ds, E2s at university, doing some PBA stuff. And then I did some SLA. And then, I saw what Freddie was working on, and I was it really piqued my interest because, obviously 5 axes and stuff. And so my work this past summer, I've been looking at the design and manufacture of antennas using this technology. So using conductive filaments, try to generate antennas.
So you mentioned Freddie. Freddie is the guy that invented this, correct?
Yeah, so he's the designer of the printer and of the slicer. I also want to credit Borut Lampert, which is a PhD student also at the lab, which contributed a lot to the project. And I also want to just credit quickly the supervisors of the research groups. So Conor Myant, David Boyle, and Steve Hodges, which have all been huge parts of being able to make this a reality.
So, what is your wish for this? Because obviously, right now, it's not essentially user friendly. It takes a lot of hands-on. There's scripts going on. You have to know Rhino. You have to know Grasshopper. What would be the ideal way for this to move forward and becoming a bit more streamlined and user friendly?
So I think the most organic way to make this grow and happen is to make it open source, and that's been done. So now the next steps that I think will help this is to get people building these machines, get people trying things out, failing and iterating to make it a better hardware, and then the most important, better software. So we need better interfaces, we need better tools, more efficient, more optimized tools that outside of Grasshopper as well. So preferably forget about Rhino. I love Rhino, but we want to make it open source. So I think those are the next steps, and that's the only way that we can make this really accessible, which is the whole point of the project.
So I have a bit of experience with Rhino, very little. It's not my cup of tea, but the fact that I have a little experience with it, and the fact that I have an engineering friend who is an expert at it, hi Nick, I feel like I'm going to have to try this out. I'm going to need an additional Mark III because I don't want to touch any of the ones I have. But yes, I definitely see this as something like this is the next step, definitely. Thank you very much, Ivan. It was an absolute pleasure.
Thank you.
And I wish you the best of luck.
Thank you.